I touched briefly on reference angles in the previous video, but reference angles are good to use when you're finding the value of any angle that's greater than 90. And a reference angle can be formed by using the terminal side of theta and the horizontal axis. So we did one in the last video where the angle was this angle. And in that particular case, the reference angle was this angle right here. Because notice the terminal side connecting down to the x-axis would be the reference angle. If it was an angle in quadrant 3, so the angle was this one, the reference angle would be the angle that would be drawn back up to this, the horizontal axis. If it was in the 4th quadrant, so we're talking about this particular angle, the reference angle would be the shortest distance to the x-axis, which is there. So those are our 3 ways we can find a reference angle. Let's show a few examples here of reference angle when we're actually trying to find one that goes with an angle. So a reference angle, let's just do this for 300 degrees. Let's do our next example as 2.3 radians. And the last example, let's do negative 135 degrees. So let's talk about 300 degrees. An angle that is 300 degrees is going to be one that kind of goes around here and lies in the 4th quadrant. So 300 degrees would be this. The reference angle that goes with 300 degrees would be this angle. So how far, if we were at 300 degrees, how far would it take to go back up to the x-axis? In this case, the reference angle would be 60 degrees. So whatever the trig ratio is that goes with 60 degrees up here would also go with 300 degrees. And that's going to come in pretty handy in just a bit. Let's also talk, because in Delta Math they're going to ask you to find the coterminal angle. And if you'll remember, the coterminal angle is going to be the angle subtract 2 pi or add 2 pi. So in this case, if I do 300 degrees and subtract 360, the coterminal angle would be negative 60 degrees. So coterminal angle and then the reference angle. Let's think about the next one, 2.3 radians. Well, 3.14 radians is here. So 2.3 radians is going to be somewhere in this area right here. So the reference angle would be this area. So how far would you have to go from 2.3 radians to get to 3.14 radians? So I'm just going to do 3.14, subtract 2.3, and we get approximately 0.8416. So that would be the reference angle. The coterminal angle would be add or subtract 2 pi. So I could go all the way around to find another coterminal, or I could just figure out the negative coterminal angle here. So I'm going to do 2 pi radians, which is 6.14, and subtract 2.3. So that is 6.14 minus 2.3. About 3.84 radians would be the coterminal angle. And I believe that would be negative because you'd have to go around this direction. Okay, the last one, negative 135 degrees, would be somewhere in here. So there's a negative 135 degrees. So the reference angle is going to be the angle that would connect you up to the x-axis. So how far would you have to go from 135 up here to this? You would go 45 degrees. So the reference angle is 45 degrees. Reference angles will always be positive. Coterminal angles can be positive and negative. So then the coterminal angle for this one would be the angle that goes this direction. So I'm going to have 360 subtract 135. So we get 225 degrees for the coterminal angle.